All right, time for another DraftPhysics.com, DebatePhysics.com also, but no, the debaters, the whatever, the adversaries just won't show up and be on the subject somewhere. So anyway, the Ian Gostling he's made a video with another one of these preposterous titles. So it says Draft Physics Perpetually Empty Arguments. So I mean, the argument is so simple. It's stated. There's a piece of an argument. You counter it. All right. So I've drawn these over and over again. I keep pointing out how many times I've had to draw it. And these cowards, okay, you just can't come anywhere near actually duplicating the argument and explaining how it's different than what I say. So I pointed out how, let's say you were just going to crash something into the earth and you're going to, go from a certain distance up in the atmosphere. And you're going to allow things to travel this distance, okay, the same distance, all right, and they weigh the same mass, so the same m values, okay, and all you're going to do is change their initial velocity going in. So one's going to have a velocity of 500, one will have a velocity of 50 miles per hour, let's say. The fact is, this will be in the gravity, the 50, for 1/10 as long, okay, because that's how it goes with velocity. You're not going to change that velocity difference. This is going 10 times faster. It will be in the gravity 1/10 of the amount of time. It will go this distance in 1/10 the time, just a fact. So this object in the gravity, let's say the gravity takes 10 seconds at 50 miles an hour, this distance, all right, it's 10 seconds, okay, which means at 9.8 meters per second, let's just call it 10 seconds, okay, that's going to be a plus 100 in terms of the velocity in meters per second. So it's going to have 150 when it hits the ground. The thing going 500 miles an hour is going to only be in it 1 second. It's going to travel exactly the same distance, so it's kind of telling, and it's only going to gain 10. That's it. That's all it's going to gain is 10 miles an hour. So it's going to hit the ground at 510. Clearly, these two objects, same masses, didn't fall this distance, didn't move this distance, and collect the same amount of energy from the distance. Clearly, what mattered was the amount of time they were in the force, how long the stream or the wind pushed them. If you change how long the forces are being applied, you change how much force can be collected, is the simple argument. Now, nothing I said here is incorrect. Nothing's invalid. They won't tell me what is wrong with anything I just drew here, or anything how any of these conclusions are not correct, absolutely correct. And so somebody even brought up in his comments section, I didn't watch the rant video, but in the comments, someone goes to the trouble to make a good analogy. Okay, that this is like thin ice. And I used to experience this because I used to have to walk to work, and I had to cross a stream in the winter. And sometimes it was frozen, sometimes not so frozen. And so there were places where there was really thin ice. And the idea was, as I knew, is if I could push myself onto the surface and get across it quickly, I'd even slide across it with my body flat, that I could change how much pressure I put on the ice, and I could change whether the ice was going to break or not. And it's a very simple argument. It simply does, as a fact, work. That if you walk slowly across the thin ice, you crash in because gravity has time to give you weight per inch. But you go quickly, gravity doesn't have time to make you weigh your full weight. So you weigh less than your full weight because gravity hasn't had time to apply enough force to give you your full weight. And so the fact is you weigh less and you're less likely to break the ice. And if you can spread it over more distance, even better. But even just walking, even if you just use your feet and you just slide across the ice, the faster you slide, the less likely you are to break the ice. And it has to do with the fact that you have to collect the force in time, units of time, billionths of a second, but you have to add them all up. Each little billionth of a second applies a little bit of pressure, a little bit of pressure, a little bit of pressure. But the pressure is collected through time. Without time, it just doesn't happen. It's all time dependent. The amount of force collected is dependent on time. Just like the sail in a boat, you need time to collect the wind. If you don't have enough time, if I shorten the amount of time you're not going to have any force applied to your sail. So it's always a time-dependent force. So that's just one of the arguments. He won't counter any of this with any kind of logic or reasoning. Nothing. Just insults and nonsense. So let's play the stupid video and see what kind of crap he spews. But again, a silly title, considering how off the subject in every fucking video he is. None of the examples have anything to do with what I have drawn here, even though this is so damn simple. He won't draw it and explain how I made an error. Oh, this insufferable asshole. But this is what people are. Insufferable assholes. I mean, he's just demonstrating. I mean, this is such crap. His argument is crap. Alright, I got to shrink that back to this kind of size. Move it up here. Yeah, making his video small is what he deserves.
If it was just...
I guess he's still in rant mode.
Just about you wanting to have somebody...
I'll speed it up. I mean, fuck. Insufferable. Little bit.
If it was just about you wanting to play with these ideas and theoretically...
Whatever. This is an argument, again, that has been pointed out to you historically. It's a 350-year-old argument, you jackass. The most famous scientists in the history of science were involved in the argument, you jackass. And as pointed out, the argument wasn't very good. Nobody made great arguments. You think denting clay with round things is a great argument? Do you think Leibniz was right? Okay, that 4 pounds dropping 1 foot is the same as 1 pound dropping 4 feet? Do you believe that? He won't answer that simple question. He's so deceptive. He's such a liar.
Wouldn't bother me at all. Fine. We all do that. Great. But what gets me is this business when you keep repeating, nobody will argue, nobody will point out where I'm going.
Yeah, that's right. You haven't done it. Not in a single video have you paid a single bit of attention to any of the details of the argument. You just change the experiment every fucking time. So you can make things be in the gravity the same amount of time. You just ignore the argument, ignore what was stated, and just redraw it in some pervert, silly way. That isn't real, that isn't the real universe.
I'm wrong. I spent the better part of my life now pointing out where you're going wrong.
And you haven't done it very well. You're such a liar and a deceiver. Go ahead, show us the clay experiment you hid from everybody because they didn't come out your way. You liar. God, what a pathetic liar to sit there and claim he has any integrity in this friggin' argument at all. How many videos do you have with the word proof where the next day you said, whoops, I made a mistake. Fuckhead.
And when I start winning the argument, you disappear.
Fuck you in the ass, still dead. You are such a dishonest, lying sack of shit. I haven't disappeared ever, you fucker. I've pointed out to you that I'm not going to argue in your comments section. I'm not going to fucking even play your fucking videos if you can't take some fucking goddamn control of the nonsense that goes on in there. You have no right to speculate on my personal life. If you're going to give me that right to do it to you, then I will. You want me to do the research and then make up some fake stories about who you are and what you are, you motherfucker? How many people you killed as a drunk driver? Shall I go into all these details? You fucker.
Yeah, you fucking throw your toys out the pram, spit your dummy out, and you turn off the video and say, I'm not playing this, because you can't play it, you lose in the argument. And then you come...
All right, but there's no losing the argument. There's 30 comments, okay, about ice breaking, and this fucking idiot can't admit that, yes, the faster you go across the ice, the less likely the ice is to break because your gravitational weight is going to be insufficient. You're not going to weigh the same. The only thing that changes is how much pressure you're putting on the ice, which is a measure of your weight. Your weight has obviously now been diluted by the fact that you are moving across the field faster than the gravity can give you weight. Obviously the truth.
back and you say, nobody will argue with this, nobody will point out where I'm wrong.
Well, where have you done it? So far, this video is just more of the same bullshit. Lies and bullshit. There's nothing on here that looks anything like this drawing. It doesn't look like any of the drawings I've previously drawn about all the other points that have been made. It's just more crap about some world that doesn't exist, where there's infinite gravity planes.
What a load of old fucking rot. I'll just have to keep doing it. When people see who's being honest and who's not.
That's right.
I mean, this business about dropping the ball.
That's all there is, right? And it's already been, we've already figured out who's dishonest. Every fucking one of you liars. Puro is a liar, a despicable lying sack of shit. He understands these arguments. Wait, you think he's as dumb as you? No fucking chance. He knows what ice is. His fucking pond freezes every year. He knows the faster he goes across the ice, the less likely it's to break. He knows that's the truth. And yet he defends you?
Load of old crap that is, isn't it? Dropping it here and it's pressing on the underside, and you say, well, disadvantage when it goes faster and goes deeper. Why is it? Does it stop pressing on the underside?
No, but it's obvious. God, it's stupid. So he's going to argue the denting clay argument, and he hasn't even drawn the object as being round. Look what he did to the object. All of a sudden, it's not round anymore. It's squishing. All right, but he doesn't understand that there's a higher percentage, okay, when you start to penetrate with a round object, okay, the very first impact is all down. It's a flat surface essentially at the bottom, very flat at the surface, very vertical at the sides. And so the first impact is always more down than sideways, obviously. Obviously the clay, as it impacts, first impact, it's all down, 90% down, okay, very little pushing sideways. And the further it goes in, it becomes 90% pushing sideways in terms of the amount of surface area that's going sideways versus, well, it's at least 50-50. So that's the change. You go from 90% down, 10% sideways. Well, actually it's 100% down, and then you get to 90, and then 80, and then 70, and then 60, and then 50, and then it's 50-50. 50% of the energy goes down, and 50% goes sideways. When you get all the way into the clay, halfway, when the object is halfway through the clay, then it's doing 50-50. 50-50 this way. 50% of the pushing is sideways, 50% of the pushing is down. The initial impact, it's 99%. So you can't figure out that difference. So the deeper you go into the clay, if you go all the way in past the halfway point, if both objects go in further than the halfway point, then they're even. Then they're both pushing the same amount, 50-50. But if one of them goes less than halfway, then this one's doing 80-20, let's say, and this one's doing 60-40. You can't understand how 60-40 and 80-20 are not the same thing, and that one is doing more work than the other one's doing. Well, it's because you're too damn fucking stupid. So I can't believe he's getting onto this subject. You lost this argument again. There's no way you can win this argument. It's crappy physics. And here you are again showing up to defend crappy logic and crappy physics.
Of course it doesn't. Presses on the underside and it's pressing sideways, pressing in all directions.
Yes, if you go through the clay to the halfway point. But that's not what he did. That's not the experiment they did, you dumb fuck. They dented the clay. They didn't penetrate the clay. That's the whole point, asshole. If they allowed the objects to penetrate the clay and then decided how much volume of clay they displaced, it would have been a fair contest. But they didn't do it the fair way. They did it the unfair way, which is typical of you people.
Requires more force the further it goes. What a load of old rubbish that is. This pendulum oscillator idea is going to prove something or not. The hell is it going to prove anything, Gary? We know it's going to go, the engine is...
A coupled oscillator. So he's saying there's no point in doing the coupled oscillator experiment. It's a really interesting phenomenon, and it clearly is going to indicate, just like the oscillating pendulum, frankly, that you have to account for it. you're going to sit there and basically say there's more or less of something. You're going to destroy momentum, or you're going to create free kinetic energy. You're going to have to explain how you did these things.
Energy's transferred backwards and forwards. What's it going to prove?
It's going to prove that when all the energy is in the light object, it can't be a different amount of energy when you put it into the heavy object, because it's oscillating back and forth. The amount of energy can't be changing, and you know that the friction, the tiny bit of it, is taking it away, and slowly it goes to less energy. Nothing ever speeds up. No energy will be gained in doing the experiment. You can just slowly watch it being lost. And the experiment is so conservative, the fact is it can go on for 10 minutes, that if you do it well, you have a very good experiment for transferring energy from a light thing. All the energy is in the light object, and then all the energy will be in the heavy object. It's a really good experiment.
Are you going to measure something about the velocity the ball is going backwards and forwards?
That's the idea, is to either do frame rates or measure the height or do what you have to do to figure out how much energy it has while it's oscillating. So the half mass is going to oscillate, the full mass is going to oscillate, and yes, you're going to compare those oscillations, say how much energy is in that oscillation. That's doable.
What? No, of course you're not. You keep saying, "Oh, by my eye it looks about right."
I didn't say anything like that. What did I say anything like that? I did the experiment. I didn't claim it was a proof. I didn't claim a damn thing. I just said, yeah, it looks pretty good to me so far. I want to do the experiment better. That's what I said. I said I intend to do the experiment better, because the experiment I didn't have measurements and I didn't have all that stuff. I didn't title any video. I have now proven and established the fact, and therefore no one needs to do any more experiments. I didn't say anything like that, moron. I'm not a liar like you. I don't falsely title videos like you pathetic liar.
From my experience of life, I can tell. Bullshit, can you? You should know this by now. Nothing to do with what it looks like.
I should know what by now? That it takes 25 times the fuel to go 5 times as fast. I should know that in my heart, because it always shows up all the time. You can just tell all the time. I mean, you can see it. Race car drivers are so afraid of hitting that gas pedal because they know every time, oh man, I'm going to lose so much gas.
Got to be measured. So unless you're going to fucking measure the thing, what the goddamn use is it? Nothing.
So again, this is just a lie that it doesn't have any use. It's an illustration of the experiment. That's all it was for. Nobody else had done the experiment. There was no version of it on YouTube. There was no nothing with 2 uneven masses doing a coupled oscillator. So I videoed it because I did do it, and I clearly didn't state, here, I have now proven. I said the camera angle isn't quite good enough. I said I need a faster, better camera to do frame rates. I said all of that crap. I said that the objects are rotating a little bit, not perfect. I said all those things. And so I suggested that somebody else should do the oscillator well. Now Despar's doing it. Now you're making this stupid video in light of the fact that he's doing the experiment. So why are you griping about this?
My experience growing up, whenever I've pushed a cart with twice the force, it's always gone twice as fast.
Yeah, that's my experience. You don't think that it's unusual for you to claim otherwise. You really think if I went on the street and asked somebody, how much fuel do you think it takes to go from 10 miles an hour to 50 miles an hour? You really think they're going to say 25 times as much? You really think so? I don't think 1 in 100 is going to give you that answer. I don't think 1 in 100 is going to answer that way.
It's never gone 1.4 in my experience of life.
Well, I mean...
Yeah, I've never saw that. I mean, I can't even imagine that I pick up a 16-pound bowling ball and I throw it down the alley, and then I pick up an 8-pound bowling ball. 8 pounds is really a light ball, and I can only throw it 0.4 faster. It only goes 0.4 faster. It doesn't even go 0.6 faster. No, it goes 0.4 faster. Less than half of the speed increase. A tiny increase, frankly. 0.4 increase? It's tiny. Yes, that's not my experience. I've gone bowling, okay? I frankly say it's not my experience. And I don't think it's any professional bowler's experience either. Again, they don't choose to use the 8-pound ball thrown twice as fast to get twice as many pins knocked over. Twice the energy. That's your theory. They don't see your theory working. They're not investing in your theory. They don't even go to a 10-pound ball or a 12-pound ball or a 14-pound ball, all giving them an advantage. And none of them choose to take advantage of what you claim to be the truth. But you don't claim it with any evidence.
Say no more.
Say no more. No evidence, just your faith. And he is a God botherer of some kind, too. That's all part of his deception. He ought to just out himself as what he's really doing this for. He is like Leibniz. He thinks this is God's work.
Well, my favourite lately is this gravity thing. You're still banging on about it. Getting it wrong in a sec. You say, let's say that you go this distance here along the surface of the Earth in 10 seconds. And we will collect a certain amount of pressure, or we'll lose a certain amount of energy to the surface in 10 seconds.
If you're in friction, yeah. So he says you're rolling something in friction. It has contact with the surface based on friction pushing it into the surface.
Now you say if we go over that distance much quicker, we use a proportion less energy to the surface in heat. We lose less energy.
Yes.
So if we go 10 times as quick, we would cover this distance in 1/10 of a second.
Right.
But in the same 1 second, in the same 10 seconds,
we travel 10 times the distance.
We would go this distance 10 times as far.
Right. Yeah. So per foot, you would lose a total of 100, let's say. Okay? But you'll lose the same 100 in the next, you have to obey Galileo's rules here, okay? It's 1, 3, 5, 7, okay? So you have to understand those proportions.
So in 10 seconds, we've gone this distance. And 10 times as quick, we've gone this distance. But still the same 10 seconds. So if it...
The same 10 seconds. So yes, you're going 10 times faster. So you're going 100 miles an hour versus 10 miles an hour. So you go 10 miles an hour, you'll lose all of your energy in this little space, and it'll be 1/10 of the amount of energy. Because obviously this thing's going 100 miles an hour, it has 10 times more energy to distribute. And the whole point is it's not going to that you're doing the 2-to-1 thing. It's not the 2-to-1 thing. It's going to go 4 times the distance. That's the whole argument. It's not going to go twice the distance. So why did he use 10? And see, he just breaks everything. Everything was really simple. He has to break it. So why don't you have something going twice the speed? Having it go 10 times the speed means we have to think about, that means it's going to go 40 units of distance. Yeah.
We've got so much pressure going across this gap on the surface, right, in 10 seconds. When we go 10 times as fast, we're going to, let's say in going across here slowly in 10 seconds, we lose 10 joules of energy to heat.
All right, so again, I drew all this, and see again how he changed everything. Why did he bother changing it? It was so simple. You have an object that's going twice the velocity. It goes 4 times the distance. Just draw that. Why are you doing this 10 times the difference in the velocity, which means you have to make this 40 times longer? I mean, just what an asshole.
All right. I've got to slow down because these arguments need to be dealt with properly. And you're
and you didn't even properly compare them. It's 2 different things, so make them 2 different lines. Here's the example for something going 10. Okay, he's going 1 mile an hour, let's say, and here's something going 10 miles an hour. And you draw the 2 lines, and you show that the line for the 10 mile an hour thing is going to be really long because it's 10 times the velocity. All right, and again, at the 1:3:5 ratio thing, which means it's going to be a huge amount of more distance it's going to travel.
Probably saying, I'm not going to play this anymore. Well, you ought to, because it debunks you.
No, it doesn't. It's like saying, look, if I want to shoot an elephant or I'm going to shoot a bullet, right? The bigger I make the divergence, the difference between the velocities I'm shooting things, I'm going to end up with a gigantic difference in the distance they move. Why didn't you just keep it 2-to-1? Again, just that's a simple enough question to ask, right? Why would he change it from, 2 to 1 to 1 to 10.
So let's say going across here in 10 seconds, we lose 10 joules of energy to heat to the surface. Now if we go 10 times as fast, we'll only lose 1 joule of heat, let's say, because you say the pressure's less. So let's say that's...
I think it's obvious it's a time-dependent force, so yes, it always gives you the right answer. So you'll never be able to say otherwise, because it's always factually true.
True, Nate, but let's say it's true. You'd lose 1 joule of energy here. But going 10 times as fast, we would have covered 10 times the distance.
No, you're wrong. So that's where you made the mistake. All right, because obviously, again, like the 2 to 1 thing, it's 4 times the distance, right? You went twice the velocity, you go 4 times the distance, not twice the distance, 4 times the distance. So it's 200 times the distance, 20 times, right? If you're going to knock it into 10 units, so you have to recognize that 10 times the speed will be 20 times the distance.
It's in the same time. In the same 10 seconds, we've covered 10 times the distance. So now, if we're only losing 1 joule here...
So again, you got it wrong. And why did you get it wrong? Because he had to change the experiment. So everybody understood the 4 to 1 thing, right? You go 4 times, you drop from 4 times the height, it only is twice the velocity. And the same inverse is true for rolling things. Twice the velocity equals 4 times the distance. So he screwed up something that was really simple and then restated it absolutely wrong. So it's not 10 times the distance, it's 20 times the distance.
Here, in 1/10 of a second, we lose 1 joule here in 1/10 of a second, 1 joule here in 1 second, sorry, because each one of these now is 1 second. Okay, in 1 second we're losing a joule, in 1 second we lose a joule, in 1 second we lose a joule. At the end, after 10 seconds, the same time, but 10 times the distance, we've lost...
So it's 20 times the distance.
It's the same amount of energy. Can't you...
No, you haven't. So, again, you did it wrong.
You see, that's proving your theory completely arse over tit again.
So, again, so how did he... What is he saying? It's the same energy. It has 10 times the energy. You have to account for 10 times the energy, not the same energy. They can't lose the same energy to the ground. One of them has 10 times the energy, you nut. How the fuck can you sit there and say, well, 10 equals 10. So going 1 mile an hour is the same momentum as going 10 miles an hour. Going 1 mile an hour is 1/10 the amount of momentum you're losing to the ground. You can't do 300 watts. Let's say if the first object had 300 watts of momentum. So it starts and it finishes and it gives away all of its energy to heat. And it creates 300 watts of heat. Okay, the object going 10 times faster has to create 3,000 watts of heat, not 300. It has to do 10 times more momentum has to go into the ground. So again, you just broke something. Again, these examples are so simple. Why can't he just draw what I draw and then explain where I made a mistake? No, he won't do it.
Or, just to rub the point in for a harder thinking, if this was rainwater coming down,
Idiot.
and this was a bucket, we go past this distance in 10 seconds, we've got half a bucket. If we go 10 times as fast, so we would now cover this distance in 10 seconds. And this section we would do in 1 second.
Again, if you're covering this distance in 10 seconds, so you're going 100, you still have half your energy. You still have lots of distance you're going to keep going. You haven't finished moving yet. You didn't stop yet. You haven't collected enough weight, okay, to stop. What an idiot.
So we'd get 1/10 of that amount of water in it. But you don't stop there, obviously, because in the same time, in the 10 seconds, going much quicker, the velocity, you don't stop collecting rain here. Gravity don't stop, does it?
Right, but you're collecting a much smaller amount. That's why you travel a much farther distance, is because you're only collecting, the other bucket per millimeter is collecting 10 drops of rain. The bucket going 10 times faster per millimeter is only collecting 1 drop of rain. You have to wait till they have the same amount in the bucket, which means you're going to have to wait a long time for the bucket collecting only 1 drop per millimeter. Retard.
So you do this distance. So if you collect a tenth of a bucket here, a tenth of a bucket here, a tenth of a bucket here, so at the end you'd end up with the same amount. 10 times the 1/10 would be the same as going past one.
It's in the gravity 10 times longer if it's, if you're going to do this right with velocities, right? Then it will be in the gravity 10 times longer. The thing going twice as fast is in the gravity twice as long. It's not in the gravity the same amount of time. If it's going twice the velocity, it goes 4 times the distance, it's in the gravity twice as long. It takes twice as long to lose the energy. Twice as long. It takes something twice as long to fall 4 times the distance. 4 times the distance, twice the amount of time to fall that distance. Oh, God, I'm such an idiot.
Section in 10 seconds, or going 10 seconds over a much greater distance, 10 times the distance, 10 times as fast.
So there's no point. I mean, look, I could draw what he's drawing and show you how it's just wrong, but I mean, I already drew this, and I've drawn it 50 times at least. At least 50 times I've illustrated the rolling object argument. And so, I mean, why does he have to keep changing the simple diagram? Why? I mean, it's just stupid. I mean, if he initiated the argument with this crap, then I would be obedient to this crappy analogy. But I mean, I can show where this is wrong because the distances are wrong. Twice the velocity, 4 times the distance. 10 times the velocity. I still, it's got to be 20 times the distance.
Come on. And this might be of interest to you. Well, I've figured out for anybody before, when this one mass ball is colliding into another and they go off at half the velocity.
Alright, so whatever this is now. So this is another fake argument not made by me. Alright, so who knows what this is. Not one of my arguments.
2 velocities of the one and then into one velocity. Where's half the energy gone? So was it top?
Oh, he's still doing this thing, right? So this is the 5 mass, and you put another 5 mass on it. So this is an experiment that's been done, over and over again, just undisputable as a fact. You take a 5 mass, you move it one, let's say 2 velocity, just to make it easy. You move it at 20 miles an hour. Well, let's just say 10. Okay, make it simple. It's moving 10 miles an hour. It weighs 5. I add another 5 to it, and it ends up being a 10 going 5. It has lost no momentum. 0 momentum has been lost. So, and that's how the experiment actually comes out. The momentum is conserved. Period. It works. And the simple point is kinetic energy theory doesn't work because I started with 200 in kinetic joules, and I end up with a product that only has 100 joules. So clearly something went wrong because the kinetic energy has been lost, and I don't have any excuse for it. And you certainly can't lose it to mechanical motion because mechanical motion uses the thing's energy. I can't have the same momentum when I'm finished as I started with and melt something. If I melt something or I break something, then I have to lose momentum. If a bowling ball hits a pin, it has to lose momentum to the pin. It doesn't get to keep its momentum. All right, so it's a real dilemma for your theory. And he's going to pretend, oh no, it's not a problem at all.
Where's half the energy disappear to? Forget friction and bloody vibration and all that. Well, it's clear to me when I really think about it. And You won't be able to follow this, Gary, because
Yeah, because it's going to have God in it or something silly. Hobgoblins. It's not going to be anything about the real world.
But some of your listeners might think.
Take a break. What an idiot. Alright, back. Alright, so just recognize that in this example with a 5-ton train, experiment, that what they're arguing in defense of kinetic energy theory is they're basically stating that you can have a zero momentum transfer of energy. That is, it is possible for a thing to make another thing move without losing any of its momentum. That it can give positive motion to something else without losing any motion itself. And I'm arguing that that is so elementally repugnant to every bit of physics. I mean, it's just not possible. You have to exchange momentum to transfer energy. You have to lose momentum if you gave energy to something else.
Can think. Along this axis we've got the force, 1 force, 2 force. And on this axis we've got the velocity, 1 velocity, 2 velocity.
So he's trying to make it into some sort of mathematical thing that velocity is an acceleration or some other kind of line that goes in a direction on a chart. That's not what it is. So you can keep pretending it's that, but that's not what it is.
So how much energy does the first mass take to get to 2 velocity?
We're not talking. We don't care how much energy it took. It's irrelevant. We're saying it has a certain amount of energy. It's moving twice the velocity. It has a velocity. We know it has a kinetic energy. Says it has a certain amount of kinetic energy. It's 2 velocity times whatever its mass is. All right, and the 2 velocity is squared. We already know what the kinetic energy is. Why do we care what it took? It doesn't matter what it took. I mean, the experiment is so simple. You have a starting condition. You have an object moving this way, okay, and it has a certain amount of motion. It has a velocity and a mass that you know. You have an end product that has a velocity and a mass that you know. They're both going in the same direction. There's just nothing to argue about here. All right? It's just a simple argument is that the experiment takes place and the thing that comes out with substantially less kinetic energy. Exactly the same momentum, but substantially less, 1/2 the amount of kinetic energy. That's not very good for any kind of notion that we have a conservation law that works. You have to understand that it failed the conservation law rules.
Here it is, it's got up to 1 velocity, and it would use 1 force to do it. And if we're going up to 2 velocity, we say we've used 2 force. That ties into what you were saying. But of course...
So again, he's saying it takes 4 times the fuel to go twice as fast. Now, he doesn't have any evidence it takes 4 times the fuel to go twice as fast. He's just going to say it.
Force used is not energy used. There's no such thing as a...
So he's saying that force is an energy. I don't know how else it could possibly be understood as anything other than equivalent to what ends up as your energy, your motion. So, I mean, certainly Newton saw the equivalency. Everybody saw the equivalency. So I don't even know if Leibniz would agree with your point that somehow force isn't energy. I think he knew force was energy.
Static force. You can't move an object. If my pencil's a force, and I want to move my hand to the right, I have to move the force with the hand.
Again, nonsense. You have to lose energy to give energy. So again, he's just denying that is the truth. That any process where motion is transferred between objects, one loses motion, one gains motion. There's nothing else. There's just the meeting of the two minds. One has a positive, one has a negative, they become the same. Everything just neutralizes, and the more contact they have, the longer their contact, the more likely they are to become the same thing. And it works with charges. So if I have a positive charge of 10, and I have a negative charge of 5, and I bang those two into each other, I'm going to end up with a net, 2.5 or whatever.
So you can't have a static force without moving. So force is not...
There's no static force. Whatever a static force is, okay, there's constant force, but there's no such thing as a static force. Oh, static how? How would it be static?
Not energy.
I mean, the whole nature of it is movement. How can movement be static?
So it's the distance moved as well. So where do we get? 2 velocity, 2 times the force, represent this amount under here. And keep it...
Again, just says you, okay? It doesn't represent anything. That doesn't represent anything. It doesn't say a damn thing. It doesn't fit the argument, okay? The argument is you have a certain amount of volume of energy, okay? You're going to lose half of it through this interaction. You have to explain how you lost half of it and kept all the momentum.
It's simple in squares. 2 times 2.
You're basically saying, look, I'm going to use the 8-pound bowling ball and I'm going to knock down twice as many pins. Well, the problem is there's no momentum to knock down twice as many pins. You can't draw the momentum diagram that would explain how you did that transfer, but somehow you had to use 1 unit of momentum and create 2 new units of momentum. You had to make free momentum. For the 8-pound bowling ball to knock down twice as many pins as the 16-pound ball, it has to make more momentum. Twice as much momentum.
2 is 4, and half of 4, because this is a triangle, is 2. So we've used 2 units of energy to get this ball up to 2 velocity. Now when they collide together, and now we've got half of that energy. Because let's take one ball for instance. The one ball is going at 1 velocity. Well, what's the work done? 1 times 1 is 1, is a half. And we've got another ball going 1 velocity. 1 times 1 is 1 and a half. Or it's a half of 1. So there's 2 lots of 2 halves is 1. So we've got 1 unit of energy represented in these 2 balls moving at 1 velocity, which is quite right, because to double the velocity takes 4 times the work.
So he says it again. Okay, it takes 4 times the fuel. You don't, but if you want to call it work, it's fine. So again, that's what you're saying. You're not having any evidence that's true. That it takes 4 times the gas to go twice as fast. You don't have a single experiment that shows that. So you can keep saying it, but it's not the truth. And it's not the truth in the impact. Twice the velocity, as the Mythbusters demonstrated, twice the velocity in a car accident does not make 4 times the damage.
Why does it? Here's 1 velocity to there. 1 times 1 is 1 and half of that because the triangle is half. 2 velocities is 1 times 1.
No. This isn't my argument, so you can make this and say this is somehow meaningful to somebody, but it's not at all meaningful to me. This is just mush. We know how much momentum the objects have, and we know how much kinetic energy they have. It's a simple experiment. You have the experiment. It's the black box. Here's your experiment. You have something going in that has 200 joules of energy. You have something coming out that has 100 joules of energy. What you have to show is not triangles. What you have to show is where did the energy go? And when you explain that the energy went into bending things or firing things or blowing things up or making all kinds of sounds and making all kinds of vibrations, you have to explain how you did that without using any momentum. That's what you have to explain. You have to explain somehow how the thing that's going to make the sparks and make things fly off, that you didn't have to use any of that fuel, that momentum, that it gets to keep all of the momentum. You have to explain that, and you're not coming anywhere close.
It is 2 times 2 is 4. Half of 4 is 2. 4 times the work required to get to 1 velocity. So half the energy...
4 times the work to get to 1 velocity. So did that make any sense? No.
...has gone because of the energy...
Obviously, the first object's going 10 velocity. The output object, so that when the first object comes out of the box, right? So you have 2 objects. You're just going to say, look, I'm combining one thing into 2 things. What happened to the first thing? It was going 10. When it comes out, it's only going 5. And the other object's going 5. So it adds up perfectly. So why are you pretending there's some sort of dilemma. Obviously, this had 10. It gave 5 to this. Now they both have 5. Where's the logical problem? Why isn't that the truth?
You had to put in to get this to go into 2 velocities. It's all quite clear. You've got a brain you can work with.
Oh, yeah, whatever. It's quite clear. So it's quite clear. It takes 25 times the fuel to go 5 times as fast. And then when something's going 5 times faster, it does 25 times the damage. Even though that's not true in any, there's no evidence, no physical experimental evidence showing that to be true.
Yeah. I know you won't even follow that, Gary.
No, there's nothing to follow. It has nothing to do with logic or reasoning. It's just absolute abstract mush.
You can't even work out the area of a square. If this is a square and it's got 1, 2, 3, 4, somebody said, what's the area?
Why would I care? I don't. The velocity is not a square. So again, a velocity is a direction, and it's an amount of motion in a direction. I mean, it's not a squared thing. It's a vector. It's a line. It's not a square. You can't have a volume of velocity. You can have a volume of momentum, but you can't have a volume of velocity.
You wouldn't fucking know. You make some excuse saying, oh, who cares? But anyway, this business about taking 4 times the energy to go twice as fast, or 16 times the energy to go 4 times as fast. No.
Why don't you prove it?
Or whatever.
What do you mean, whatever? Let's hear that again. So why don't you just get to that business? Why don't you explain why you have no physical evidence? It's been a fact for now 350 years. Your side, your Leibnizians, have been saying it's a truth. So why do you have 0 evidence of either it taking that much fuel or it creating that much damage? You have no evidence, no experiment to point to. Nothing. Explain that. Explain why it's okay that you have 0 evidence.
Taking 4 times the energy to go twice as fast, or 16 times the energy to go 4 times as fast. No. Yeah. Or whatever. It's not the velocity that matters, Gary. It's the acceleration. It's the period during the acceleration.
Yeah. So again, what do you mean it's not the velocity that matters? If something's moving in space, it has kinetic energy based on its velocity. What do you mean it has something to do with the acceleration? There's a meteor heading for the Earth. It's moving a certain velocity. What the fuck does the acceleration have to do with it? And as I pointed out, as it plows into the Earth, it'll gain so little velocity from Earth's gravity because it'll be in it so little amount of time. So it won't make any difference at all. So its velocity in space is what matters. Its velocity is its energy. Who cares how it was accelerated? Who fucking cares?
That's when you're using the extra energy. Going at the same velocity, it doesn't really equate, because then it's just a matter of friction absorbing energy, and you could make it a friction-free surface, or something, so there's no loss to windage.
Well, yeah, and then it goes twice the distance, so then all of a sudden your distance equation goes out the window. All of a sudden distance doesn't make any sense because it's not going to work for your side, because something going twice the speed is going to go twice the distance.
Wear resistance from friction. And then you wouldn't be using the 16 times the fuel to go twice as fast, or whatever it is you say.
I don't say it, you say it. So again, he won't even defend his own theory. That's the theory's implications. It's kind of clear. You said it right in this video. It takes 4 times the fuel to go twice as fast. You said it. You argued in defense of it. And yet you don't have any evidence to support that argument. Don't you understand how bogus that is? God damn, what a fucking piece of shit.
You only do that when you're accelerating. It's the acceleration period that matters.
So again, he said it again. What does that have to do with the experiment? So I just did the experiment. I have a box. I'm put into the box 300 joules. I get 150 joules out of the box. Explain to me how your acceleration argument has anything to do with it. How did it magically kill half the energy? Destroy it. Make it disappear from the universe. How did it do that?
That's what you keep ignoring, because it sounds better than, if I go in a car 4 times as fast, I'm using,
16 times the gas.
16 times the fuel, and then anybody sort of says you don't think, in your death cult might say, oh yeah, that sort of sounds right. Well, it ain't right. It's only the acceleration period. That's right.
What does that mean? It's only the acceleration. It's either 4 times the fuel or it's not. It either takes 4 times the fuel or it doesn't. It either takes 4 times the fuel to go twice as fast or it doesn't. You can't have it both ways. You can't say, yeah, it's twice the work, but it's not really work. Because it's just the acceleration part where there's work, but there's no work. The real work isn't twice as much work or 4 times as much work or any number amount of work. There's no real work. I mean, what are you saying, you fucking lunatic? How can you sit there and defend it takes 4 times the work, you said that word, and then say, well, it's only the acceleration work, so that's not real work somehow because it's acceleration work, and so it doesn't count. So it's not 4 times the work. Even though I said it's 4 times the work, it's not 4 times the work. It's only 4 times the work. Don't you understand? I mean, can't you understand how 4 times the work is not 4 times the work? When it's accelerated work?
So that's a fucking faux pas argument as
well.
well.
Oh, fucking goddamn amazing. What an amazingly silly person.
Oh yeah. Inspired by Pyro. You didn't play the...
What a fucking cunt video. Yeah, it's just too stupid a video.
This video, because it's probably the most...
I talked about this very experiment 2 years ago. And 1 year ago, I made it clear how you can't change this outcome. It's impossible. Twice the velocity is going to be twice the distance because you're not taking any energy out of the objects. You're not testing how much energy they have. Obviously, one object has a velocity this way, and the other object just dropping only has momentum in one direction. So it's only got energy in one direction. So when it hits the ground, it's just going to have, boom, that energy. The other object's going to have not only energy going this way, but it's also going to have energy that way. So whatever its velocity is going to add more energy to its potential impact. It can make a bigger crater because it actually has 2 velocities. But I mean, that's not the point anyway. The point is it's already established they fall at exactly the same rate. They collect force in the downward direction at exactly the same rate because they're in the gravity exactly the same amount of time.
Powerful argument against you. This mass will hit the ground at the same time as one drop.
Yeah. Yes, I said I made that exact argument. I don't know how we could be this stupid. The same time means the same force, retard. I mean, I'm making the argument that it's a time-dependent force. So I'm obviously saying, yes, if you're in the force the same amount of time, you'll collect the same amount of energy, and you'll have the same amount of energy in that direction on impact. Where have I said something wrong? Amazing.
Exactly the same land together, which is proving that this...
It's proving that distance doesn't decide how much energy you get. It doesn't decide. Except, like I said, when you're falling a finite amount of distance in a finite amount of time. So if the time and the distance are coherent to each other, that is, you're not comparing 2 different distances in 2 different times. Obviously, the distance from here down is the same distance. The amount of time they spent in the gravity is the same time, and the work going down in that one direction is the same amount of work in that direction. Anyway, it's no point.
Mass moving through the gravity can have the vertical gravity can have no effect on it whatsoever. If it did, it would change the time that it...
Right, but if you did change the time they were in the gravity, then you're going to change how much they're going to be pushed by the gravity, how much work is going to be done on them by the gravity. So if you make this go theoretically fast enough, it will go faster than the curvature of the Earth. And when it achieves that, that means it's going to keep getting affected by gravity more and more and more and more and more over a much longer period of time. And it will be, in fact, collect a lot more gravitational energy. But it always loses it to the fact that the Earth keeps falling away from it.
Landed on the ground. Completely destroys your argument.
There's nothing to destroy. I mean, it's just pathetic. You won't be able to play any clip from my video or to show any part of my video where I said anything about these things landing at different times. Never happened. He's just such a liar.
This is a physical experiment. We could prove you. I don't think you deny it. It's well known. If there was any difference in the faster mass moving through the gravity, if it was affected, it would land at a different time to the one just dropped. And you don't play it. And
it's not, they're in the gravity the same amount of time. Again, if I'm calling it a time-dependent force and they're in the gravity the same time, why would I argue they landed at different times? Or why would I argue they gained different amounts of energy? I'm not arguing any of that crap, you liar. So put them in the gravity a different amount of time and then explain. Like allow the one to drop 4 times the distance and explain why it's only going twice the velocity when it's 4 times the distance. Why isn't it 4 times the velocity?
I don't suppose you'll play it now, because it completely destroys your
You're a
argument.
liar. Such a liar.
I don't know how much longer I want to go on, because one thing after another, but the scale argument, when you say you dropped a 1 mass from 1 height, and it registered a 1 mass weight, and then you dropped it from 4 times the height, and it registered a 2 mass weight. So, the trouble is what you're missing, you see, and is that
So it's going to keep trying to say that somehow if I put 10 pounds on a scale, that I did 1 unit of energy. And if I put another 10 pounds, do exactly the same action, I did 3 units of energy. Because now I have 4 units of energy. So twice the weight is 4 units of energy. So even though I did this, and that's 1 unit of energy, and then I did this, which was 1 unit of energy, I end up with 4. And he says that makes sense to him. Obviously, it's idiotic.
presents 4 times the energy, because that scale has got a spring in it, and it's a well-known fact in physics for 200 years.
It's just so disgusting that somebody this ignorant of history and physics history could say something about any well-known fact. It's so obnoxious.
Whatever, that a spring displays twice the distance, has 4 times the energy.
So again, where is this a fact? Just idiotic. Twice the compression is only twice the weight. It is not 4 times the weight. It can't do 4 times the work. It can only do twice the work.
Nobody denies that except you.
Oh, amazing. I'll bet you want to bet real money on it? You know, we just survey regular people and see how many of them believe, okay, that 20 pounds is really 40 pounds.
So that scale, in representing twice the weight, is actually representing 4 times the energy. So it's very difficult to prove anything.
So again, he's saying that Hooke's law isn't well-established physics. That's what he's saying, clearly. I mean, because that's a violation of Hooke's law. Hooke's law clearly states that the spring compression is proportional to the amount of energy put in. No doubt about it. 2 units of mass put in, 2 units of compression of the spring.
To you, like I did a spring launch experiment, launching things vertically into the air.
Yeah, rubbish experiment, frankly. I explained how you had 7 springs not connected to each other. So, yeah, and so when you launch something, the springs were flying all over the place. So obviously all the energy in the springs were shooting each other into the air. You weren't launching the object with the spring, you were launching the springs with the spring. And you didn't pay any attention to those critiques. You just pretended it was a rational, sensible experiment when it was a piece of rubbish and shit.
Twice the compression of the spring would launch the mass 4 times as high, and you come up with some fucking god-awful stupid excuse, like the springs weren't tied together or some crap.
Right. So yeah, he just doesn't think it matters that, you know, as I pointed out with the Newton's cradle, how different the efficiency is. So if I take the Newton's cradle and I do this, all right, less than 10 contacts, and then I do the Newton's cradle this way. All right, just 1 ball. Oh, look at that, it's still going. Yeah, look at the elk, it's still going. Look at that, it's still going. indicating, look, I lost what? Half the energy fundamentally, right? In the first experiment, I had to have lost at least half the energy. So you don't think that's significant when you're doing an experiment. Losing half the energy isn't significant. You're an idiot. So again, that's the point here, right? He's an idiot. So he doesn't think quick release is a thing. He doesn't think that, oh, it doesn't matter how many little broken pieces of spring I use. It's still the same thing as a functional spring. I mean, just what a pile of shit.
Crap like that. But anyway, these things are very difficult to argue with you as springs because you deny the fundamental idea of how they work. So
I deny until I see evidence, okay? So I don't claim to. I've said in videos, I'm not a spring expert. I didn't do any research on springs. I haven't done a ton of spring experiments. All I've stated is my personal experience with springs, which is, yeah, if I compress it twice as much, it has twice as much energy. That's my impression, okay? So, yes, that's been my experience. Playing pinball, for example, you pull the little plunger back with the spring and the ball, and yeah, I pull it back twice as far, the ball goes twice as fast. That's my experience.
Well, it's useless trying to argue it with you. And while I'm on a roll, the hypocrisy that comes out of your fucking gob, and you criticise people, how dare they talk about Newton and put words in his mouth. He never would have said this and that. To think that greats...
He didn't say it. So again, he's going to defend the slander of Newton with mv squared when he didn't do it. It wasn't his physics. He didn't believe it. It's an overt text. I mean, Dispar, are you so much of a liar that you won't inform Ian that he's wrong? That Newton explicitly said twice the force, twice the velocity. 3 times the force, 3 times the velocity. Explicitly said it. There's just no doubt about what he believed. No doubt. And this asshole is defending this slander, that Newton was a Leibnizian. He was not.
Greats like Nosferatu, who's the other bloke? Newton's fucking arch enemy, as you say, the calculus bloke. I've forgotten his name, but what a clever bloke he must have been. If it's true that he got the kinetic energy thing. What a fucking genius he must have been. And the hypocrisy.
Died penniless, and no other scientist even grieved at his funeral. No, but they didn't even show up to say goodbye. Newton was buried as a god. So you're saying that's winning. He obviously lost the argument decisively, and the very crap you tried to defend in the beginning of this video, this stupid denting clay experiment, is the only thing that revived his dead physics. That's the real history, and you're just again lying, okay, about the real history because you don't know it. You can't even remember the guy's name after I've said it so many times. Leibniz. You can't even remember the fucker's name. And you're going to sit there and say, you know the history? You're the authority? Somebody should believe what you're saying? You fucking piece of crap. Outrageous. You pretending that you know something, that you did any research at all.
When you call other people's unfair, how many times have we heard you decrying what somebody says and calling them all sorts of names and cheats? You call what's it a cheat, don't you? Nosferatu, you got it all wrong. It's great.
I don't know what what's Netsuratfu? What are you talking about? Satan or something? What the fuck are you talking about? What are you talking about, you lunatic? It's like saying I said Mary Poppins said something. I didn't say anything about what Mary Poppins said.
Bloke. I'm calling him Nosferatu, I don't care anymore. And you call him a cheat and a liar and whatever. You called Walter Lewin a cheat and a liar. That great physics.
Yeah, exactly. And I demonstrated why I'm making the accusation. I mean, clearly you can look right at the carts and see that the one can't really have twice the mass. There's just not enough parts on the cart. There's no way it can weigh twice as much, logically. So unless it has a secret hidden piece of lead on it somewhere, they can't be the weights he says they were. And let's understand, Professor Lewin's the one who called somebody who told him his 2 voltages in the same place theory was wrong, and just said he's a flat earther. So that was the extent of his counter argument, to call him a flat earther. because he dared to disagree with the magnificent Professor Lewin, who basically, he did, molest some of his students.
Teacher, one of the best I've ever seen, and you call him a cheat and a liar, and he's still alive. You decry people whether they're dead or alive. You do it all the time when it suits you. But then you complain about what other people...
Whatever a decry is, okay? I don't decry anything. I just, everything I say, you can sit there and quote it somewhere and prove I was wrong. So go ahead and prove me wrong about the things I said about Professor Lewin. Show where I was wrong. I had no right to draw the conclusion. I had no right to watch the experiment, say, what is that stupid clay doing on that cart? And then analyze it further and figure out, oh yeah, there's no clay on the other cart. That's obviously a mass problem now between the two carts. One cart has 2 clumps of clay on it, the other cart has 0. And it's supposed to weigh twice as much. Well, how the fuck can it weigh twice as much when it's 4 units of clay behind?
People are saying. Are you suggesting that you somehow have the trumps cards on all these greats in physics that got it wrong and sort of been idiocratic? Somehow you've trumped them all?
It doesn't matter whether that's a fact or not. I'm saying that obviously I've pointed out, do you actually believe that Young's diagram of the double slit experiment is accurate? Is that your contention, that Young was right? Okay, so go ahead and argue that he drew a double slit pattern when he drew a single slit pattern. It didn't have the envelope. It didn't have the necessary components. Are you going to lie and sit there and say it was a double slit pattern when clearly it wasn't? He didn't do an analysis of the double slit. He did an analysis of a single slit because he put the two surfaces so close to each other they became the same point source. I've explained all of this. The fact that I'm right and Young was wrong is either a fact or it's not a fact. Is it my fault that it's a fact? No, it's not my fault that I'm right and he's wrong. That's not me being bad, you moron. That's you being bad for sitting there and making a god out of a totem pole.
You? I'm not going to go into personal attacks, but come on, you've got it right and they've all got it wrong. For 200 years, it's all wrong.
350 years.
I'll finish on this, and this is to any of your listeners as a test of your own intelligence. This is what Gary says. I've got a 1 ton weight on the ground here, and I go up 1 foot.
I mean, this is pathetic. As I have multiple times pointed out, you can make that 1 ton weight. You can use, if I want to use 6 million joules of energy to lift it, I can. All I have to do is lift it really slowly. So if I lift it slowly, I can use a zillion. I could use a quadrillion. I could use all the energy in the universe if I take a long enough time to lift that weight. Because I'll have to fight the gravity the entire time. I'm holding it against the gravity. So yes, you can make something more work, but you can't optimize any better than the same velocity it would fall with using that to launch it. That's the most efficient way to get to that height. If you give it more velocity, you have to use more energy. Yes, you'll get to the height more efficiently, but you'll go much higher than you need to go, using more energy than you needed to use. There's an ideal speed. That's just a fact. There's an ideal speed you go through gravity and you'll maximize your efficiency to get to a location. So for every location you could pick in the atmosphere, I can show you a speed that's the ideal speed to get to that location and no farther. And it's always going to be that more efficient. And if I go faster, I'll have to use more fuel, but the fact is I will go a lot farther. So the further I aim for, the less fuel I use per foot. The faster I go, the less energy per foot I will use. Fact. Okay, I'm saying that's an absolute fact. The faster the launching speed, the less energy I use per foot. That's an absolute fact. I'm sure NASA knows it. I'm sure the guys making this spinning thing that's going to shoot satellites, I'm sure they know all these facts. That's the maximum. You want the highest efficiency, increase the amount of speed that you launch something with, and you'll do the least amount of work for the most amount of distance.
That amount of energy to lift it up 1 foot. I can repeat it 4 times. I have to think now what you do say, Gary, because it's so freaking ridiculous.
What I do say is when a weightlifter lifts a weight, it isn't lifted, okay, that speed, and I'll go this speed, the same speed, and I'll go the same speed, and I'll go the same speed. They lift it by jerking it, okay? They're trying to get a maximum velocity, so at least for half the lift, they're doing less work. Nobody lifts anything the same velocity, okay, per foot. That's not how to maximize the efficiency. The maximum efficiency is to do the 1, 3, 5, 7 thing, to increase your velocity. Increase your velocity of your lift, and then your momentum will carry you through the distance.
Obviously, it's 4 times the energy, but you say, Gary, no, it's only 2 times the energy. Say we lift.
I don't say that, so again, you're lying again. I just stated for you that you can make it 10 times the energy, you can make it 500 times the energy by just lifting it slower. So the slower you lift it, that's right, the more work you'll do. Fact. It's not a disputable fact. That it's an absolute fact. The slower you lift it, the more absolute work you're going to have to apply to it to get it to the top of that surface. The slower I lift anything on this plant, any mass, the slower I lift it to the top, the more work I'll have to do on it. And the faster I can get it to that point, the less work I'll have to do.
This at 1 speed, and we carry on. We lift at all stages at the same speed, so speed's not an argument.
Of course it's an argument. That's exactly how nothing falls at the same speed, shit for brain. That's the whole point. The first part of the journey's really slow. The second half of the journey's really fast. That's the whole point, you fucking retard. It's not the same speed.
Whatever energy you use to do the one height, we carry on lifting it at the same speed. It's got to be a multiple of 4, hasn't it? If you don't agree with that, then there is something wrong with it. There is something wrong with you. You're probably suited to Gary, following Gary. Anybody with common sense knows that if we lift this up here one distance and we lift it up to the second, and that's a one amount of energy.
And again, that's not how anything falls, and it's not ideal. So the ideal thing is to jerk it to this surface, not to lift it at the same speed. If you lift it at the same speed, you're going to lose energy. You want the optimum thing to do is to give it the initial velocity capable of getting it to the surface you're aiming for. Fact.
Whatever it is, and we do it at the same speed up to the next one, it's got to be a double. It's got to be 4 times the energy to get 4 times as high, which is why when you drop something from 4 times the height, it's twice the velocity. It's 4 times the energy when it hits the ground, getting back what you...
Yeah, and I can make it 8 times, I can make it 16 times, I just lift it up slower. The slower I lift it, the more work I'll do, period. Proving it's a time-dependent force. Proving that time will decide how much work it is. So take more time to lift it, you will do more work. Take less time to lift it, you will do less work. Fact, 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 you dumb fuck.
That to lift it up. And Gary says you can lift a one mass up of only twice the energy cost, even though it takes 1 unit of energy here, and I can go 4 times as high and only use...
Yeah, I can do exactly what it does when it falls. I can give it an initial velocity, and it will go that initial velocity, and it will lose half its speed in this 3 units of distance, and then it'll lose its last unit of speed in the 1 unit of distance. It'll do exactly 1, 3, 5, exactly in reverse. And that's just a fact. So the faster I lift the object, the less energy I will have to use to get it to the surface. Fact, 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 fact. You're a lying sack of shit to say otherwise, or to say I've said anything wrong when I've stated that simple truth that yes, you can waste energy by lifting it slower, or you can maximize the efficiency by lifting it at the free fall velocity.
Twice the energy. I mean, come on. Please, please.
Alright, just what a despicable hunk of shit. So nothing I drawn. No example I've used, replicated. So no effort whatsoever to honestly argue my arguments. Instead, he's arguing somebody else's arguments. Straw man personified. Okay, and that's all he's got. is lies and distortions. That's all they have, are lies and distortions. So there's comments 0. Oh, good. Yeah. There shouldn't be any, because the argument is really stupid.